Our final afternoon speaker is Avi Loeb, and Avi Loeb, he serves as the chair of the Harvard University's Department of Astronomy, founding director of Harvard's Black Hole Initiative, director of the Institute for Theory and Computation within the Harvard Smithsonian Center for Astrophysics, chair of the Breakthrough Starshot Initiative, chair of the Board of Physics and Astronomy of the National Academies, and a number of other organizations that he belongs to. I'm very appreciative of the time he's willing to spend with us today. As you can see, he's a very busy individual. And just in case you haven't already got it, I know a number of you have bought his book. I've got it right here. It's the most recent one is Extraterrestrial, the First Sign of Intelligent Life Beyond Earth. And it's a great mix of both some personal biography, and it has some hard science as well as some contemplation of what our contacts with intelligent life would appear like and whether we've actually already done that or not. His talk today will be focusing on extraterrestrial life. Are we the sharpest cookies in the jar? And it's one of the most exciting frontiers in astronomy. And he's going to talk about some of the first identified clues close to Earth in the form of that weird interstellar object, Oumuamua. And I don't want to keep going any longer because we've wasted enough time trying to get this going. So if you're ready to go, then we're all set to go. And I apologize again for the delays and the technical issues.
Okay, thank you very much. So I will try to keep it short since we lost 15 minutes. I hope you can see my screen.
Yes, we can.
Okay. And so let me open the slide deck. Okay. So what I will focus on today is the book that I published 7 months ago called Extraterrestrial. You can see it in the middle. And if I had to summarize it with one sentence, I would say, when you are not ready to find exceptional things, you will never discover them. I also published what you see on the right side is a textbook that I published a couple of months ago with Harvard University. Okay, thank you. What you see on the right side is a textbook that I published a few months ago with Harvard University Press called Life in the Cosmos. It's more than 1,000 pages long, and it provides the scientific background for the search for life. What you see on the left is a photograph of a photograph that was taken by a German photographer named Herlinde Quilbel, who came to my office a couple of years ago and asked me to write on the palm of my hand the question that I regard as most important in science. And I wrote, "Are we alone?" This photograph that you see on the wall was presented at the Berlin Brandenburg Academy of Science and Humanities in October 2020. Oops. Okay. Actually, a few weeks ago, I received an email from a rabbi in a congregation in Ann Arbor, Michigan, who said that he gave a sermon for the high holidays, the Jewish high holidays, about my book. And that illustrated to me that the content of the book have implications for a broad range of topics, including religious beliefs of people. And when a colleague of mine saw this email, he said, "Next time we meet for dinner, my wife and I will ask you to give a sermon." To which I replied, "I would never lead a congregation whose members agree with me." And also a couple of weeks ago, there was a call from Congress to establish a permanent office that will address unidentified aerial phenomena called UAP. And this should happen within the next 6 months or so. So that's a very significant change at the government level. Now, the one thing I've learned from practicing astronomy over several decades is a sense of modesty. I call it cosmic modesty because we know that not only we are not at the center of the universe, but also what we find in our backyard is not special. The Earth-Sun system is replicated throughout the Milky Way galaxy. About half of the sun-like stars host a planet the size of the Earth, roughly at the same separation. So altogether, there are more habitable Earths in the observable volume of the universe than there are grains of sand on all beaches on Earth. And when you see a painting like the one depicted in the middle of this slide of an emperor being very proud of himself because he conquered a small piece of land here on Earth, that's not very impressive because it resembles an ant hugging a single grain of sand on the landscape of a huge beach. But that's not surprising for me, because when my daughters were young, they thought that they are the center of the universe, that they are the smartest. And then when we took them to the kindergarten, that changed their perspective because they met other kids. And so our civilization will mature only by finding others. And most stars formed billions of years before the sun. We know that because we can observe the star formation history of the universe. So we know that most stars formed billions of years before the sun. So if you imagine another sun-like star having an Earth-like planet that had similar conditions to Earth, and a technological civilization like ours that developed artificial intelligence systems there, like we develop right now. These systems drive cars, and in the near future will make medical decisions. So just imagine sending them into space. They will be autonomous. We don't need to give them guidelines. We just train them through machine learning early on in their life. And then just like our technological kids, we send them into space. And so if we can imagine doing that, then other civilizations may have done that 1 billion years ago. And what that means is that if it sent AI systems that are equipped with 3D printing, such systems could replicate themselves. They can repair damaged components, but also produce copies of themselves out of the raw materials that they find on other planets. The question is, do we live in such a reality? 1 billion years is enough for such systems to populate the entire Milky Way galaxy, even at the speed of chemical rockets that we send out all the time. So are we living in such a reality where this was done 1 billion years ago? The answer should not be provided by philosophical reasoning. The answer should be derived by observing through telescopes. Because if we just remember that what happened 4 centuries ago when philosophers said, we don't want to look through Galileo Galilei's telescope, we know that the sun moves around the Earth. That only maintained their ignorance. The Earth continued to move around the sun. And currently we send space missions that use this fact. So the fact that Galileo was put in house arrest, that his view was not popular at the time, is irrelevant. Reality is stubborn. Reality is whatever it is, irrespective of how many likes it gets on Twitter. So people can ridicule the search for extraterrestrial neighbors, but that will not get rid of them. And my point is that science should search for evidence, not assume that our prejudice must be right. So it's not a matter of philosophical discussion. It's a question of looking at the sky and searching for equipment that might have been sent by others, just like we sent Voyager or New Horizons. And that's what the Galileo Project is all about. In July, a few multi-billionaires visited the porch of my home. And altogether, they asked me questions about my book, Extraterrestrial, that I mentioned at the beginning. And they gave me $2 million to conduct research along these lines. And by now, there are more than 80 people engaged in this project. Within 2 months, we are purchasing instruments, and we have a very active scientific agenda. And if you want a motto for this research project, and by the way, it's a standard scientific research project. We use telescopes to find evidence for what is out there in the sky. Because extraordinary conservatism leads to extraordinary ignorance. That's the lesson from the experience of Galileo Galilei 4 centuries ago. And the point is that we should dare to look through telescopes for the answers. So just to give you an example, these unidentified aerial phenomena, suppose you have a human-sized object at a distance of a mile. With a meter-sized telescope, one can obtain a megapixel image of that object. Megapixel is 1,000,000 pixels, so that means that you can resolve the head of a pin on such an object. You can tell the difference between a label saying made in China, made in Russia, or made in exoplanet X. It's not a philosophical argument. We can just obtain a high-resolution image of a UAP and figure out the nature of this UAP. That's all. We need big enough telescopes. We need full control over the instruments that we have, not relying on cameras in a jittery cockpit of a fighter jet, but rather do it the way scientific experiments are done. And what happened until now, over the past 70 years, is that this subject was ridiculed. And therefore, the scientific community never engaged in it. And then the public was left to speculate. But the strange situation is the government, which is the most conservative organization, filed a report to Congress admitting that there are objects which are not identified. And so the goal of this project is to develop the instruments and systems, telescope systems, that would identify the nature of these objects. And if we find that all of them are either birds or human-made, the drones or airplanes, so be it. But if we find one, just one, that is not terrestrial in origin, not natural or human-made, that would have a huge impact on the future of humanity. So it's worth checking. And then the second component of the project is looking for objects that enter the solar system from outside that do not look like the comets or asteroids that we have seen before. And one of them is Oumuamua, the object that my book, Extraterrestrial, focuses on. Currently, we have $2 million, but we are fundraising because we really need 10 times more in order to do a comprehensive study of the sky in this context. And you can see the link below for this project. As I mentioned, there was a report delivered by the Office of the Director of Intelligence to Congress that reported about at least 143 incidents where objects were identified as real objects by multiple instruments, but their nature is unclear. And that means that they behaved in ways that are not consistent with human-made technologies. And most of the data is classified, but if we assemble new data from a scientific project, it will not be classified. The sky is not classified. We will have the data open, and we hope to assess the nature of unusual objects in the sky this way. And here is an illustration of the members of the scientific research team. There are by now 30 within the research team, most of them astronomers, exceptional scientists. We have a scientific advisory board. Oh, by the way, among the members, we also have the principal investigator of the New Horizons mission to Pluto, Alan Stern. And in the scientific advisory board, you might recognize some names. Among them is also Stephen Wolfram that developed Mathematica. We have a philanthropic advisory board and a public outreach component, and many research affiliates. So there is a lot of excitement about this project. A lot of people offer their expertise. I received thousands of emails within a week from the public announcement that came out at the end of July, on July 26th, 1 month after the Pentagon report to Congress. So it's really the future of humanity that we have to worry about, because right now, all our eggs are in one basket here on Earth. And there are risks from internal threats that involve the change in our climate, wars, or self-inflicted technological wounds that we have. And there are also external threats. We know that the dinosaurs thought very highly of themselves 100 million years ago. And then 66 million years ago, there was a giant rock the size of Manhattan Island that tarnished their ego trip by hitting the ground. So, we don't want to be impacted by a similar asteroid, and we're searching the sky. But eventually the sun will boil off all oceans on Earth within 1 billion years from now. We will have to move elsewhere into space. So here is a brief history of my journey from a farm, actually. I'm a farm boy. I was born on a farm 59 years ago, to space exploration. So you can see me on the top left at age 6. And I used to collect eggs every afternoon. You can see it in the second image. And then jumping forward at the bottom left, an entrepreneur from Silicon Valley named Yuri Milner came to my office, sat on the sofa in front of me, and asked me whether I'm willing to lead a project that will visit the nearest star within our lifetime. That was in 2015, when I served as the chair of the astronomy department. I served 3 terms between 2011 and 2020, and just finished my term last year. So I realized that's a very challenging proposition, because light takes 4 years to reach us from the nearest star, Proxima Centauri. So to get there in 20 years, let's say, requires a spacecraft that moves at 1/5 of the speed of light. That's 1,000 times faster than chemical rockets. But we identified the technology within 6 months that can do it, and announced it on April 2016 in the company of Stephen Hawking and Freeman Dyson, as you can see in the bottom middle photo. This is an artist's illustration of the solar system. You can see the sun on the left, and the nearest star system is a 3-star system, Alpha Centauri. Among those 3 stars, the nearest is Proxima Centauri. And Proxima Centauri has 12% the mass of the sun. And therefore, it's a dwarf star. Most of the stars in the Milky Way are much smaller than the sun. And it has roughly half the surface temperature of the sun, 3,000 degrees. So it emits mostly infrared light. But it so happens that there is a planet 20 times closer to this faint star than we are from the sun. And so it so happens that this is the habitable zone around this star. That's where the surface temperature of the planet is roughly that of Earth. And the planet is so close to the star that it's tidally locked, just like the moon is. The moon is showing us the same side at all times. This planet has a permanent day side and a permanent night side, as it moves around every 11 days. So my daughters say that if we ever go there, they want to live on the strip that separates these 2 sides. That's where you can sit on the porch and watch the sunset forever. The sun never sets. on this trip. How do we get there? Well, the idea is to push a very thin film of material that we call a light sail with a very powerful laser beam. And one can equip the light sail with a camera, navigation device, communication device. This is called the Starshot concept, and you can see it illustrated in this video. A large collection, an array of low power lasers combine their beam to 100 gigawatt beam that shines on a sail that is roughly the size of a person and weighs a few grams. And if this laser shines for a few minutes on that sail, it can bring it to a fifth of the speed of light over a distance that is 5 times the distance to the moon. And the advantage of this method is, since you are pushing the spacecraft with light, it can reach the speed of light. And it doesn't need to carry the fuel with it. And after the first few minutes of the launch, the journey takes 20 years to the nearest star, Proxima Centauri. And the hope is we could take a photograph of the planet and send back that image that will inform us whether there is life on the planet. Of course, it will take another 4 years for this signal to get back to Earth. So altogether, 24 years, a very long time. And there is a big challenge of detecting this signal. Humans are not really equipped to travel across vast distances between stars. It's only equipment that can do it. Now, in principle, one can launch a sail close to the speed of light by parking it close to a star that is about to explode. When a star explodes, there is a flash of light that can carry a sail of the type that I mentioned up to the speed of light if the sail is parked at 100 times the Earth-Sun separation, roughly. I show that in a paper that I published. And it's just like having surfers on the beaches of Hawaii that are carried by a giant wave, except here the wave is a flash of light. Another metaphor is the dandelion seeds that are carried by the wind that you can see on the right side. Now, the most important question is, are we the sharpest cookies in the jar? Are we the smartest in our cosmic neighborhood? And by the jar, I mean the Milky Way. Probably not. You know, when I teach at Harvard, I usually tell the students that half of them are below the median of their class, and they get upset. But that's a statistical fact. In any class, half of the students are below the median, period, irrespective of how good they are. But they have a difficult time adapting to that. So I would argue we are probably in the middle of the bell-shaped probability distribution of intelligent life forms in the Milky Way galaxy. We are not the sharpest. And another indication for that is if you open the news every day, and you would realize that, you know, we are not really intelligent, because the way I define an intelligent culture is a culture that follows the guiding principles of science, namely cooperation and sharing of evidence-based knowledge. And if you look at human history, we're not cooperating. The latest example, COVID-19. When it came out from Wuhan, China, the information was not really shared about the nature of this virus. It could have saved a lot of lives if it was shared. And the other component that we are not really practicing in policy matters is decisions based on evidence. We tend to think that we know the answer in advance without looking at the evidence. And that's a big fault of human nature. So without a prejudice, let's just be open-minded and look at the sky. And try to search for evidence of other civilizations, other kids in our cosmic block. And the first object that came into the solar system from outside that was spotted near Earth was identified in October 2017 by the Pan-STARRS telescope in Hawaii. It was given the name Oumuamua, which means a scout in the Hawaiian language. You can see it circled in blue on the background of stars in this image. And it came from a very special frame of reference called the local standard of rest. That's the frame that you get to when you average over the motions of all the stars in the vicinity of the sun. Sort of like the local galactic parking lot. And this object was at rest in that frame. Only 1 in 500 stars is so much at rest as this object was. So it definitely did not originate from the nearby stars. And it was just like a buoy sitting at rest on the surface of the ocean, with the sun bumping into it and giving it a kick, like a giant ship. And as it approached the sun, it was tumbling, and every 8 hours, the amount of sunlight reflected from it changed, and the change was by a factor of 10. That meant that it has a very extreme shape. Projected on the sky, the amount of area that it showed us changed by a factor of 10 as it was tumbling. So just think about a piece of paper tumbling in the wind. The chance for us to see it edge on is very small, and a change by a factor of 10 in the area is huge. And when an attempt was made to model the variation of light of Oumuamua, at the 90% confidence, it was concluded that it's disc-like, it's pancake-like in its shape, because when considering the possible orientation of the object, you can see on the left, the diagram shows the probability distribution. The likelihood is close to 1 in the regions that are dark, and there is a lot of dark or black on the left side here, and it shows that it's very likely that a disc-like object would have reproduced the light curve. Whereas on the right side, you see a cigar-shaped object, and for that you had to fine-tune the orientation of the object when it was observed. So much more likely at the 90% confidence, it was pancake-shaped. And then the most unusual fact about it is, well, it wasn't a comet. The Spitzer Space Telescope looked very deeply, and you can see the image on the top right. There was nothing detected from Oumuamua, no infrared emission, and that put very tight limits on any dust or carbon-based molecules in its vicinity. Definitely not a comet. We didn't see a cometary tail visually, but the limits are very tight on any traces of carbon-based molecules. So not a comet of the type that we have seen for sure. And then it exhibited a behavior that is usually attributed to a comet. It had an acceleration, an excess push away from the sun that is not gravitational in origin. And if it would have obtained this acceleration from evaporation, then about 10%, a tenth of the mass of Oumuamua had to get evaporated. That's a lot of mass. We would have seen the cometary tail. So the only explanation that came to my mind, given that the excess push declined inversely with distance squared in a smooth fashion, I suggested it's a reflection of sunlight from this object that is pushing in. And for that to be effective, the object had to be very thin, sort of like a sail, but nature doesn't make thin objects of that type. So I suggested it might be artificial in origin. And that's the fundamental question. Was Oumuamua natural or artificial? Again, it's not a philosophical question. If we had good enough data, we could have figured it out. Now, in September 2020, there was another object discovered that exhibited an excess push away from the sun by reflecting sunlight without a cometary tail. This object was given the name 2020 SO, because people thought it's an asteroid. But then the astronomers realized, oh, if we extrapolate the trajectory back in time, it actually came from Earth. In fact, it's a rocket booster that was launched by NASA in 1966. And we know that it had thin walls, and that's why it exhibited a large area for its mass, so it could have been pushed by reflecting sunlight. We know that it's artificial because we produced it. The question is, who produced Oumuamua? And I should emphasize, 2020 SO was a rocket booster. It was not designed to be a light sail. It was just thin, that's all. So, you know, Oumuamua could have been a plastic bag, trash, space trash, could have been something else, could have been a receiver. As long as it was thin, it would have exhibited this excess push as a result of reflecting sunlight. So what are the anomalies of Oumuamua? Well, first of all, we didn't expect to find it based on a paper that I wrote a decade earlier. It also originated from the local standard of rest. Only 1 in 500 stars are so much at rest in that frame as Oumuamua was. Its brightness changed by a factor of 10, implying that it has a very extreme shape, most likely pancake-like, the 90% confidence. And there was no dust or gas detected around it. Now, the deviation from a Keplerian orbit suggested that maybe it's pushed by reflecting sunlight, which implies a very thin object, potentially artificial. Now, most astronomers said, oh no, it's natural, business as usual, forget about it. But then a few astronomers tried to explain those facts. And I should say, the data on Oumuamua was derived scientifically. So there is no doubt that this is the data. It was collected in the standard scientific way. So avoiding the need to explain the data is not good scientific practice. Just saying business as usual and ignoring the anomalies is not the way science should be done. And there were a few groups that tried to explain the data. What did they come up with? One of them suggested, well, maybe it's a cloud of dust particles, 100 times less dense than air, a dust bunny. The problem with that, even though it's very lightweight, the problem is material strength. When it gets close to the sun, it will get heated by hundreds of degrees and will not maintain its integrity. A cloud that is 100 times less dense than the steam you get out of a coffee, of a teapot. Another suggestion was maybe it's made of hydrogen, pure hydrogen. We've never seen a hydrogen iceberg before, but that was the suggestion. Maybe this is produced in some environments very different from the solar system. It needs to be very common. And then we wouldn't see the hydrogen because it's transparent. So it's a comet made of hydrogen. The problem with this is that hydrogen evaporates very quickly. So it wouldn't survive the journey through interstellar space. We showed it in a scientific paper. Then there was a suggestion, okay, maybe it's a nitrogen iceberg that was chipped off the surface of a planet like Pluto. The problem here is the mass budget. There is not enough nitrogen. So you can see here some numbers, one related to the hydrogen iceberg on the left. The characteristic lifetime of a hydrogen iceberg is only a few million years, and that doesn't allow such an iceberg to travel a significant distance across the Milky Way galaxy. It needs to originate from a percent or so of the size of the Milky Way, and there are simply no molecular clouds that can make such icebergs within that distance. And then the nitrogen iceberg model is mostly problematic because such an iceberg will get evaporated by cosmic rays, actually over a time scale that is similar. And there is just not enough nitrogen by several orders of magnitude to explain Oumuamua. And we showed it in 2 papers. And there is just, even if you take all the nitrogen that there is in stars, it's just not enough. And in fact, the people that proposed the hydrogen model wrote a paper a month ago, and you can see the middle sentence of the abstract, where they admit that the hydrogen and nitrogen models have serious difficulties. So I rest my case. First of all, the alternatives to an artificial origin suggest something we have never seen before. And second, they have serious difficulties. So we should keep on the table the possibility that it's artificial. That sounds like common sense, but it's rejected by most astronomers that were not part of these studies. And the way I think of it is when we walk on the beach, we see mostly rocks that were naturally produced, but every now and then we see a plastic bottle, and that could be Oumuamua. It implies that there is a civilization out there that produced it. And just imagine a caveman finding a cell phone. The caveman would say, oh, it's a rock of a type that I've never seen before. Just like saying, Oumuamua is a hydrogen iceberg, or Oumuamua is a nitrogen iceberg. It's a rock of a type that I've never seen before. That's the natural explanation that the caveman would give to a cell phone. But then, if the caveman would press a button, and it will record his voice, and then press another button, and it will record his image, he would realize that it's not a rock. So it's the beginning of a learning experience for us. And what I really hope we will do is press the buttons on weird rocks like Oumuamua that represent something that we've never seen before. Because the worst that we can do is say business as usual, ridicule the subject on Twitter, and move on to consider things that we already know. That would be just like the caveman throwing the cell phone away and maintaining his view that it was just an unusual rock. Now, there was another interstellar object observed called Borisov, and that looked just like a comet. And so I was asked by my colleagues, doesn't it imply that Oumuamua is also natural, given that this one looks natural? And I said, yes, this looks natural, but if you find a plastic bottle and after that you find a rock, it doesn't make the plastic bottle a rock. And of course, a picture is worth 1,000 words. In my case, a picture is worth 66,000 words, the number of words in my book. I wouldn't need to write the book if we had an image like this one, obtained by OSIRIS-REx, that landed on the asteroid Bennu and took a sample of the rock that it will bring back to Earth in 2023. So, if an Oumuamua-like object is a nitrogen iceberg and we land on it, we could easily tell. It's not a philosophical question. And one thing to recognize is that the play, the cosmic play, is not about us. We are born into this world like actors put on a stage. And the stage is huge, 10 to the power 26 larger than our body. That's the universe, the observable universe. And the play started 13.8 billion years ago at the Big Bang. We just came at the end. How dare we think that the play is about us? It's not about us. We are not central players here. And out of modesty, we should check if there are other actors. And we can check either by looking for relics of the type that I mentioned, or by looking for industrial pollution in the atmospheres of other planets, or looking for very bright beams of light that are used to propel light sails, or looking for city lights on the night side of Proxima b. Now, Enrico Fermi, 70 years ago, raised a paradox. He said, during lunchtime at Los Alamos, he said, "Where is everybody?" Now, that is very presumptuous, because it assumes that they care about us. But if we are not that interesting, if we are one ant out of many on the sidewalk of the Milky Way, why would they visit us? Why would they have a party in our backyard? And it's quite possible that most of them are dead by now. And we spent our time trying to establish a phone conversation, looking for radio signals from them. That's not the right approach, because if they're dead by now, the best approach is archaeology, as we do here on Earth, to search for relics that they left behind. Just like the spacecraft that we sent out. And my hope is that it will help us improve the way we behave, in particular with each other. Because if you look at human history, one thing you find out is throughout history, humans were driven to feel superior relative to each other. The best example is the Second World War, where the Nazi regime triggered the death of 75 million people. That was 3% of the world population in 1940. Just think about it, it's 20 times more deaths than the total number of deaths triggered by COVID-19, that virus that we talk about for a year and a half. So 20 times more were triggered back in 1940 by a group of people that felt superior relative to other people. Now, if we find a civilization far more advanced than we are, sort of like a smarter kid on our block, it will make all of our genetic differences among us completely meaningless, negligible compared to the difference between us and them. And so my hope is that this will inspire us to ignore our differences and cooperate as equal members of the human species. Thank you.
Thank you very much, Avi.
Thank you all for joining. I'm grateful for the questions. It was great fun. Thank you.